Hello and welcome to Honors Function. We are now beginning Unit 5 about sequences and series. The first lecture focuses on sequences. Let's begin by going over an intuitive understanding of sequence and series. A sequence is an ordered set of numbers. For example, this represents a sequence. This is the first term of the sequence. This is the second term of the sequence. This is the third term of the sequence, so on and so forth. So here the rank matters very much, okay? While a series is an infinite sum, so if you take these terms and you add them all together like this, you find a series. Okay, so we're gonna have to try to understand what it means to add an infinite number of terms together. But that will come later. For now, we're going to focus on sequence. Let's define a sequence formally. Suppose we have a function whose domain is the set of natural number and whose codomain is the set of real number. This function is called a sequence. That's it. It's a sequence. Now, to any natural number, you associate a real number, okay? And a of n is the nth term of the sequence, nth term of the sequence. The sequence is called a. Okay, of the sequence A. Now, we don't use the functional notation A of n, but when we talk about sequence, we use the subscript notation, A sub n, okay? So a sequence, you can write the elements of a sequence as A sub 1, that's A of 1. The second one is A sub 2, A of 2, A sub 3, etc., 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 A sub n. And the one following A sub n is A sub n plus 1, okay? And then it goes on forever. Now be careful, A sub n plus 1 has nothing to do with A sub n plus 1, right? I mean, this is the next term. This is the next term of A sub n. While this is just A sub n plus 1, you add 1 to A sub n. They have nothing to do with each other, okay? In general, of course, in general. Before we go over some examples of sequences, let me show you the last notation for a sequence. So to represent this set, we use a shorthand notation for it, okay? To represent the sequence A, we use a notation A sub n from n equals 1 to infinity, okay? This is the sequence A. This is basically this function here. So we do not use functional notation at all for sequences, although by definition a sequence is a function whose domain is a set of natural number. We don't use the notation at all, but we use notation specific to sequences, okay? Last remark, you don't have to start at 1 actually. There may be sequences that will start at 6, 7, 8 or wherever, okay? You can start your sequence, for example, you could have a sequence Bn where the first term is actually n naught, and n naught is a natural number, okay? And it goes up to infinity. Now that has to be there. There are an infinite number of terms in a sequence. Let's now go over some examples of sequences. So in these examples, I want you to write the first 5 terms of the sequence, okay? So I'll detail the first one, but it's pretty easy actually, you will see. Most of the time it's pretty easy. So n here starts at 1. So I'm gonna write here, for the first one, I'm gonna do a table. You do not have to do a table, okay? I'm gonna start the first one at 1, and then 2, 3, 4, 5, and that's going to be the last. So if n equals 1, what is A sub 1? So it is 1 plus 1 over 1 squared. So 1 plus 1, 2 over 1, it is 2. If n equals 2, what is A sub 2? So it is 2 plus 1 over 2 squared, 4. So it is 3/4. what is now the third term of the sequence. So n equals 3, 3 plus 1 over 3 squared, 9. And so the third term of the sequence is 4 over 9. What is the fourth term? 4 plus 1, 5. 5 over 4 squared, 16. And the next one is going to be, okay, look, at this point, we should have a pretty good understanding of what's going on here. 2, 3, 4, 5 at the top, and then 1, 4, 9, 16. Square at the bottom, and natural number at the top. So it's going to be 6 over 25. And if I were to go further, at this point, I'm understanding the sequence. I really don't look at that anymore. Okay, the next one would be 7 over 36. And the next one would be 8 over 49. And etc., 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 right? We have a pretty good understanding of what's going on now. All right, you're going to do number 2 and number 3. Let me do number 4. Okay, so this one seems to be a little bit more complicated. Let's check it out. So what do you do right here if n equals 1? Where are you if n equals 1? So negative 1 to the first power is negative 1. So it is negative 10 plus 100. Negative 10 plus 100 is equal to 90 is the first terms of the sequence. All right. If n equals 2, what do we have? Negative 1 squared, that's plus 1. So it is 10 plus 100 divided by 2, 50. So it's 10 plus 50, it is 60. If n equals 3, what's going on? So if n equals 3, what do we have? We have negative 1 cubed is negative 1. Negative 1 times 10 is negative 10 plus 100 over 3. So that is negative 30 plus 100 over 3. So it is 70 over 3. All right. N equals 4. So this is going to be a plus 10 now. So I get what's going on with the 10. Minus 10, plus 10, minus 10, plus 10. Okay. I'm not sure about the 100 here. And then I take 100 and I divide it by 4. Right. So actually, let's see. So this is 25, so 35, right? But if we keep the over 4 notation, what do we have? We have 40 plus 100 over 4. So it is 140 over 4. So yes, it is 35. We can simplify like that. I'm trying to get an understanding of the sequence. So right here, if I stay with 100 over 2, so this is 100 over 2, right, the 50. So what do we have? 10 plus 100 over 2. So it is 1, so it's 20 plus 100 over 2. So it's 120 over 2, okay? So it's 120 over 2. And here we had 90 over 1. So 90 over 1, 120 over 2. 70 over 3, 140 over, oh, not 40 right here, 4, sorry about that, over 4. Okay, I'm not sure I'm getting that here. I know it's going to be negative 10, and here I'm going to have plus 100 over 5. So what's the next one? So negative 50 plus 100 is 50 over 5. And the next one would be what? The next one would be plus 10, all right, plus 100 over 6. 100 over 6. So that's 60 plus 100 over 6. It would be 160 over 6. So there are two types of numbers here. They're the number with the negative 10 right here. So we got 90 over 1, 70 over 3, 50 over 5. I think I'm maybe getting it. 90 minus 20 is 70. 70 minus 20 is 50. I'm guessing the next one should be 30 over 7. Right? That should be the next one, I think. Let's see. It is negative 10 plus 100 over 7. Yep, that works. 30 over 7. Okay, let's capture the other series now. 120 over 2. 140 over 4, and 160 over 6. So here, the next one, I believe, should be 180 over 8. Okay. Now, if we want to study the sequence, we would have to look at these numbers more closely, but that's not what I want you to do at this point. Okay. Please go over number 5 and 6. I'm gonna start number 7. Whoa, what is this sequence? This is awful. What is that? This is actually one of the most famous sequences in all history of sequences. Now, of course, it never shows up like that. We'll talk about the sequence more later, okay? But hey, I want the first 5 terms. Alright guys, we're not gonna get the first 5 terms here. That would be too much work. Let's get the first 4 terms, okay? 4 terms. So if n equals 1, what do we have? So we have 1 over root 5 times 1 plus root 5 over 2 to the power of 1, right? So here, I don't need this. And then minus 1 over root 5 times 1 minus root 5 over 2. Okay, so what's that? This is 1 plus root 5 over 2 root 5 minus 1 minus root 5 over 2 root 5. Okay, well, the denominators are the same, right? So it is 1 plus root 5 minus 1 minus root oh, careful, the minus distributor here. So it's plus root 5, right? Plus root 5 over 2 root 5. These will cancel. What do you have at the top? 2 root 5. 2 root 5 over 2 root 5. Wow, that's 1. That is 1. Okay, this is my first terms of the sequence, 1. Alright, so let me erase that and let me go with the second term of the sequence. So let's take n equals 2 now. So if n equals 2, what do you have? You have 1 over root 5 times 1 plus root 5 over 2 squared minus 1 over root 5 times 1 minus root 5 over 2 squared. Okay? Alright, so what do we have at the top right here? 1 plus root 5 squared. 1 plus root 5 squared is 1 plus 2 root 5, and root 5 squared is 5 plus 5. Over what? Over, careful, 2 squared times root 5. So it is 4 root 5. Alright, I hope that was clear, but I'm going to do the same on the second one, right? So you have a minus right here. Minus what? Minus. What are you squaring here? You're squaring the top. 1 minus root 5. So it is 1 minus 2 root 5 plus 5. Okay, hey, I'm going with the formula here, okay? This is where a formula makes sense. Divided by what? Don't forget to square the bottom also. Right? Divided by 4. But 4 times root 5. 4 root 5. Right? So, careful, the negative sign distributes everywhere here. So, you have 1 plus 2 root 5 plus 5 minus 1 plus 2 root 5 minus 5 over 4 root 5. 1 will cancel, 5 will cancel, and it is 4 root 5, right? 2 root 5 and 2 root 5. 4 root 5 over 4 root 5. Again, it is 1. Again, it is 1. Okay? Alright, guys. I'm going to let you do the third one, but I can tell you, you shouldn't find 1. Please compute the third value of the sequence, and you should find 2. The third value of the sequence, if n equals 3, if you take n equals 3, you should find a3 equals 2. So make sure you can find 2. You will have to expand a cube. So you should know the formula, right? It's not that difficult actually. Be careful with the formula, but you should find 2. And if you keep on going, the next term of the sequence, if you are very courageous, should be 3. Okay, let's stop this famous sequence right here. Please try to check out this one. This is just some algebra. Let's move on. So sequences are given in 3 main ways. The first way is the definition we just gave. A sequence is just a function whose domain is a set of natural number. This is called the explicit expression of the sequence. Okay, why explicit? Because the nth term is given in function of n. So explicit. A second way to express a sequence is recursive. A recursive expression of a sequence. So what is this? How do you express a sequence recursively? First, you're going to give the first term of a sequence, and then you're going to give a recipe to go from one term to the next. Okay, so in this case, an plus 1 is given in function of an. So basically, I'm telling you how to climb the ladder here. For example, if you think of a ladder, this is actually what the students last year had in mind, and I kind of like that, right? I kind of like that. In the explicit way, here we go, check it out. In the explicit way of a sequence, you can directly jump on the rung n. Okay, you can directly jump there. In the recursive way, I'm giving you the first rung, and I'm telling you how to go to the next one. Okay, so from the first, you're going to go to the second. From the second, you're going to go to the third. From the third to the fourth. From the fourth to the fifth. And so on and so forth until you reach the rung n. Okay, so recursively, you have a recipe to go from one term to the next. Okay, but not directly to go to the nth term. You got to go through a whole series of terms before. Finally, the last way to write the sequence is just with a list. Okay, so for example, with a list, we could write this. This is a sequence. It's written with a list. I'm not sure how I go from one term to the next. I don't know if there is a way to express it like that. I don't know if there is a way to express it like that. It's just 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. I'm not sure how I get the next term. Of course, there is a way, but I'm not sure how to get there. It's not obvious to me. I got to do some research, okay? So these are the three ways to write the sequence. Let me now show you the recursive way, which is a very, very important way to write the sequence. So in the next series of example, again, I want you to write the first 5 terms of the sequence, but they are all given recursively, all right? So the first term is a1, so this one is given to me. How do I get the second term? Well, check out the recipe. How do you go to a2? So a2 is what? It's 2 plus, if n is 2, n minus 1 is 1, right? 2 plus a1 over 2. So it would be 2 plus, what is a1? 1. 2 plus 1 over 2. So it is 3 over 2. So my sequence is 1, 3 over 2. What's the next term? All right, let's see. So a3 would be what? So a3 would be 2 plus a2 over 2, right? So it is 2 plus 3 half over 2. 3 half is 1.5 plus 2 is 3.5. 3.5 is 7 half over 2. 7 fourth. 7 fourth. Please use your calculator right here if you want to, okay? All right, a4. What's a4? a4 is 2 plus a3 over 2. So it is 2 plus 7 fourth over 2. Here, how about we multiply both sides by 4 just to make our life easy, right? So 4 times 2, 8. 8 plus 7, 15. 15 over 8. 15 over 8 is the next one, 15 over 8. So I'm getting a pretty good handle of these right here, right? I think the next one should be 16, I'm pretty sure. I'm not sure what's going on at the top. We'll see. All right, so a5, what is a5? So it is 2 plus a4 over 2. So it is 2 plus 15 over 8 over 2. So check out, over 2. Check out what happens right here to the 15, right? You multiply both sides by 8, right? So there you're going to have your 15 plus 2 times 8. So plus 2 times 8, that's 16. And here 8. So it is, yeah, I got my 16 right there. And 2 times 8, so it is 16. So 16 and 15, 31. So I've added to 15. What did you add to 15? 2 times 8, right here, right? 2 times 8. So I believe I'm going to add to 31 2 times 16. So I think the next one should be 32 plus 31 over That's 2 to the 4th, 2 to the 5, 32. And I believe the next one should be 64 plus, what is 32 plus 31? 63, over 32 times 2, 64, right? Check them out, but I think I'm on the right track here. Do you see how recursive works? The second example is going to be a little bit easier. Let me do number 9, and I'm going to let you do the others, okay? Number 9. So, A1 is 1. What is A2? A2 is 1 plus 1 over A1. So A2 is 1 plus 1 over 1. It is 2. What is A3? A3 is 1 plus 1 over A2. Right? This is what it says right here. So it is 1 plus 1 half. So it is 3 half. Here, let me keep as a fraction 3 half. What is A4? It is 1 plus 1 over A3. So 1 over 3 half. So it is 1 plus 2 third. So it is 5 third. And finally, what is A5? It is 1 plus 1 over 5 third, right? So it is 1 plus 3 fifth, so it is 8 fifth. Okay, I'll stop here. There may be a way to go from one term to the next like that. I see the 3 goes there, and then the 5 goes at the bottom. I'm not sure where the 8 is from, but anyway, I'm not going to try to figure this one out. I'll let you dive into it, okay? Please do the other examples. The last thing I will tell you, this is a very interesting sequence, number 11. I hope you will like it. This is another very famous sequence called the Fibonacci sequence, okay? Do number 11. The last thing I will tell you is another way to represent a sequence, which is graphically. So, of course, because a sequence is just a function, okay, when n is a natural number, you can graph the sequence, but you see right here, my input are only natural number, right? I don't have a continuous graph like that. That doesn't make sense. It wouldn't be a sequence. And so I can graph a sequence and I can see points, okay? Take a look at this sequence we've studied earlier. It looked very complicated. Check out the output. Wow, there's something pretty amazing in the output right here. We'll talk about this sequence more. Thank you for watching.